Send model mobile. Very good afternoon, my dear participants. So welcome back for the second session of the FDP program. So now I request Ramya Madam to introduce the speaker. The speaker will be talking about virtual constructions. Let us be virtual. I request now Ramya Madam to welcome the speaker of the day.
Thank you, sir. Good afternoon, one and all. Welcome back to the session 2. It's my privilege to introduce Dr. S.P. Srinivasa Padala. Dr. S.P. Srinivasa Padala is currently Assistant Professor in the Department of Civil Engineering, M.S. Ramaya, in University of Applied Science, Bangalore, since 2020. He completed his MTech and completed his PhD in construction industry, construction management from IIT Delhi. Prior to his PhD, he worked in construction industry for 5 years in planning and contracts department. His research interest includes change management, project scheduling, optimization, visual design and construction, cost control, machine learning applications, and sustainable construction. Till date, he has published 10 journals, 9 conferences, and 5 book chapters. He is also a reviewer for International Journal of Construction Management, Taylor and Francis, and Engineering Architectural Construction Management. He is also peer reviewer for International Conference on Sustainable Design, Engineering and Construction, USA. We are very happy to have you here, sir. I welcome you, and I welcome all the participants. Thank you.
Thank you. Thank you for giving invitation to me. So can I share my presentation?
Yes, sir, sure.
Is it visible? Nice. First slide.
Yes, sir. Yes, sir.
Yeah, fine. Thank you. So I am audible also, right? No issue, right? No
Yes,
issue
sir,
with
you are
the
audible.
audio. So okay, just for to minimize the network, any network interruptions and all. So I will just off my video. Is it fine, right?
So sir, PPT is not visible actually. Folder is visible.
Is it? Okay, just hold on. Now it is visible, right?
Yes, sir.
Slide.
Yes, sir.
It's fine, right? Okay. Okay, just what I was trying that just to minimize any network interruption, I will off my video. Is it fine? So that
Yes,
I think
sir.
people will not have any disturbance, because I was listening in the first session also. There was some issue in network issue there. I thought maybe
Yes, sir. Welcome, sir.
Yeah, fine. Sir. So I will again enable my video later.
Okay, sir.
Okay, thank you. Okay, then I will start my session.
Yes, sir, please.
Yeah. So once again, thank you, Sir MVIT, Department of Civil Engineering, for inviting me to present my research interest in this FDP session. And so this is my title of the topic: Virtual Construction, an application of building information modeling. So it is presently, one of the what I can say growing area basically in terms of jobs also. Nowadays, if you just type a word called BIM in Google, you will find a lot of job roles like BIM engineers, BIM modelers, and they all come under construction management again. So present, if you see my profile also, I have done my MTech and PhD. Also, I worked in industry also for 5 years in a construction industry. So my area is construction management. So it falls under that domain basically. Like if you're interested to pursue career in this particular domain, you have to you're required to do MTech in construction management. That's the requirement, because in BTech we don't have much courses. Now I think as per NIP we can able to introduce more electives, But as of now, still we have only 2-3 courses. With that, we cannot become skilled in this area. So we have to require students. If any student is interested to pursue career in this particular topic, which I'm going to present, so they have to do MTech in construction engineering. So I will represent. I will start with the. Okay. Thank you. Thank you. By mistake, I muted my audio. So I just started now only. I did not discuss anything. So what I was telling that, so there are, if you see the title, it's a virtual construction, then hyphen application of building information modeling. So I was saying that virtual construction is nothing but building a project virtually before you start the project, and using a platform like BIM. So BIM is again it's a concept where we apply several digital technologies in to develop a models virtually, basically. So if you see the BIM in short form, we call as BIM, but it is a nothing but building information modeling. So when I say building, it's not a structure; it's just a verb. Build, developing also you can use. So you have to develop the information, then you have to model it together. Then I in BIM you have I also information. Information nothing but design information. We have cost information, time, economics, soil data, then all the components data, reinforcement details, all the information. Just imagine in a project how much information you will have. Start. You cannot just you can imagine for a few seconds you will list down more than 30 to 40 types of information. If you talk about doors, tiles, for each component, again you have color of the tiles, thickness of the tiles, then what is the design of the tiles and the composition of the tiles. Like that, you will have several information which we use in our project. So it is very difficult to manage that. So in BIM, what we do is we integrate this various information in one integrated platform that's called building information modeling. So using BIM, or building information modeling is one platform is there. Using that, we can actually use the concept called virtual construction. So that's the topic I'm going to present today. And so this entire topic falls under construction management. As you know, now, my field, my MTech and PhD in construction management, right? So if you want to pursue career in this particular area, like in job, even from teaching point of view, or even from industry, if you want to work in industry also, in this area particularly, then you should have at least MTech in construction management, basically. So not in other domains are different, but this MTech in construction management, if you do that course, then you will come to know these various topics. So yeah, so if you, when you talk about the construction industry, so like the students, even a faculty, even everyone, even the parents, laymen, general people think about industry like this, right? They think about using heavy equipments, very risky, right? It's a very huge equipment should be used in the site. Then you will see on the right hand side several laborers are climbing and fixing all the reinforcement here, and you see in the bottom also how it looks. So completely, not many. If you see current trend also, like no one will want to pursue career in this field because this is how people imagine. But what is happening here is, if you see in this slide, who is working actually? Here the equipments or equipment operators are working, and then laborers are working, and you will see a lot of other materials are there in the site. Actually, we as a students, if you talk about students, you will not be actually dealing with this. I mean, when you go to site, definitely you have no role basically. Even as a supervisor, you cannot help them because they are already experienced. All the laborers, all the high technology equipment, they can manage a project. I mean, not they manage, but they can execute all the daily activities. Now the question comes, then what is my career in this industry? Like if you see this, so that's the topic all about virtual construction. Basically, what I'm trying to talk about this here is, you need to develop this virtual construction skills actually help you to get the white collar job, simply in office job basically, where you can sit in an office, work from 9 to 5 for 5 days, take 2 days off, and you can focus on that type of task in a project basically. So that's the type of skill I'm going to present in this presentation. So that's our construction industry. When you talk about industry, this is how it looks. So this virtual construction can help us to resolve many issues here, because too many, you can see the picture again, too many tasks are happening, right? We have heavy equipments, a lot of labor are working, so anything can go wrong. And if anything go wrong during this execution, during in the middle of the project, then everything will be kept on idle, the project will get delayed, we can't do anything. So what if we can identify these mistakes early as possible before you start the project, then it will be it will be good for everyone. That's the current scenario basically. So if I talk about the growth also, even because of COVID, we are behind 2 years. But assuming there is no COVID, in 2019, there is an article published by consultants in India Today article. So what you can see in this slides, that they have predicted that our industry, construction industry, expected to be USD 1 trillion by 2030, and also 13% of GDP it can contribute by 2025. Now it will be 2027 because because of Corona we are behind by 2 years. So again, construction is poised to become the largest employer by 2024. So means you can say 2025 at least. So I'm talking about next 3 years. Right now I know that because of COVID and all, we don't have funds in industry. All the funds all the budget which are used for COVID and all, COVID vaccines and all. So we don't have funds. That's the reason currently there is a fall in the market. But you know that a lot of growth is there. Like infrastructure requirement is too high for our country because we are developing nation. But last one you can see here. The interesting is, over next decade, the industry required around 4 million construction engineers on average. 4 million. I'm talking about only construction engineers, not the design engineers. Only the construction engineers. So when I say construction engineers, again, you should not go back and think about this one. Here there is no construction engineer standing here. I'm talking about someone else which you don't know maybe, which I will show in the next slide. So I'm talking about the virtual design engineers or virtual construction engineers, or the engineers who have analytical skills who can work on this area. So you can see the requirement is around 4 million engineers or construction engineers we require by next decade. So again, there is another article which is published in this year in the beginning of the year. So in that article, it is by startups. The one of the company called Startups. So they have written one article based on a survey with the various industries. So they found out that the top 10 construction industry trends, which are already implemented in this year only, which is going to be there for next decade. So you can see the various topics I have highlighted. On the left hand side, you can see we have building information modeling. Then we have construction robotics. Then we have construction project management. Again, advanced building materials. So I think that's all about this workshop also. In this workshop or in this FTB, so other speakers are talking about already talked about advanced building materials, and we have another session on tomorrow also. Then offsite construction, nothing but a precast. Then construction worker safety. Then construction monitoring. Then green building. Then we have 3D printing. So 3D printing also already the previous speaker explained. The brief introduction is given on that. Then we have connected construction site. So these are the top trends which are going to implement, is already there in the India. And you see on the left hand side and right hand side, what you see here is these all are the consultants. They are all actually nothing but companies which are going to provide the solutions on all these things. And I can guarantee that you may not hear about these companies. In India, I'm talking about these are the companies who are there. They are in overall the world, MNC companies who operate from various countries, and these companies also there in India also. See that visual live, then you have robotics, then you have e-tech, then you have graphene glass, then like this you have several companies like, right? You see on the last one, Safe AI. AI, you know what is AI? Many people are talking about currently about AI, and it is written Safe AI. And so those are companies are there which are implementing all these latest technologies in our industry also. So just imagine the job requirements. Like if you want to come into this, like we have different roles, and all these jobs, what is exactly? They are not site jobs. Like you go to the site and stand in a hot climate and work 7 days, right? It's not that. You cannot do all this thing in site. You will be working in actually office only. But actually, you need to build a lot of skills in this. Again, it's not easy to get white collar jobs in our industry unless you have these type of skills. So again, there are several articles are there. What I'm trying to show that I'm just trying to justify my topic, like why it is important. So I'm using some articles which are from very top consultants in the world. So there is another article from McKinsey. I think everyone knows about McKinsey Global Institute. It works for every industry. For example, L&T has hired McKinsey Institute or McKinsey company for managing many issues in the projects. So McKinsey is one of the top leading consultant in many companies, especially construction industry. In our industry also, McKinsey is there. So they have McKinsey has again given an article. So you can see that it has also talked about same way but in different way. Like if you compare with previous slide, it also explained or given
So
5
slides
trends.
not moving.
Slides are not moving. Is it not moving now?
Yes, sir.
From here it is moving. So can any other student or can you check?
Yes, sir, it's not moving.
Not
Can you
moving.
please?
Well, we'll check. Just I'll just reshare. I think. So I'll share my entire screen. I think that will work. Now it is moving.
Yes, sir.
Yes, sir. Yes, sir.
Now it's moving. So please stop me again next time also if something happens. Like if it is not moving, not audible, immediately please stop me so that I will recheck. Okay, so I was in. Did you see this slide? Can anyone tell which slide I stopped? Is it this slide or? Okay, it was in first slide only. This one.
Yeah, yeah.
Okay,
Yeah.
fine. Okay, fine. So this is clear, right? So what I was telling that. So whatever I explained is there in slides only. So what I was telling that there is a huge growth in the industry also. Then these are some of the trends which are there in our industry. Like so, what happened? There is one company called Startups. They have, after doing a survey with various companies, they have mentioned these are the top 10 technologies which are going to implement, which are already there, and going to be there for next decade. So like building information modeling, like robotics, then construction project management, then advanced building materials, offsite construction, worker safety, construction monitoring, green building, 3D printing, which is already discussed in the previous, right? Then connected construction site. So you can see on the what I was telling that on the left hand side, right hand side, there are some logos given. They are nothing but your companies. And I was telling that you may not hear about these companies. Like these are so many companies actually there in our country and overall the world who are working in these concepts. So what I'm trying to say that there are a lot of requirement is there in this field basically, and it is one of the future. I don't say this is only the future of the civil, but apart from design, but in construction planning part, what I'm trying to say is we have a lot of scope where actually you can sit in office and work. In layman language, if I say, it's more like an office jobs basically, but with a lot of skills you can only get. So I was telling that there is another company called McKinsey Global Institute. So is slide changing right now? The slide changed?
Yes, sir.
Okay, fine.
Yes, sir.
Okay. So this another company is there, like McKinsey Global Institute. So it is one of the leading consultant who are for L&T. There are many companies are there which is providing services. So they also given one article. They mentioned 5 trends that will shape construction and capital project. So they are given 5 trends. You can see on the top left hand side, high definition surveying. Then we have next generation 5D building information modeling. Then future proof design and construction. Then Internet of Things and advanced analytics. Then on the left hand side, again, you can see digital collaboration and mobility. So these are some of the trends they have mentioned, which will shape the industry. Like it will change. So again, if you see in these also, who is going to work? Not the labor or operator, equipment operators, any supervisors. They all be working the site. But these are technologies which you will be using, right? So it's a different skill. So it's all comes under digital construction organization. So what it says that the future organization will become digital organization. Like we know, like in everyone talks about now digitalization, starting with Paytm, right? It's from 3 years we're hearing about digital everywhere. Same thing it applicable even in our case also. So the future will be like not the normal construction industry, but it's a digital construction industry. So this is another article called by World Economic Forum, Boston Consulting Group. It is also one of the leading consultant in India. I mean, it's in abroad also, as well as in India also. So they also given again top 10 trends which will change the industry. So again, if you start with here, prefabrication is there. Now you know that SOBA developers, SOBA company is there, where my students are placed in that company recently. So the entire Bangalore now they are making prefabrication. Entire Bangalore, whatever the projects they are executing, everything in the Bangalore it will become precast. Then we have advanced building materials. So this is again repeating 3D printing. So all the previous session speaker has already given introduction on advanced building materials in 3D printing. Then autonomous construction is more into the robotics, augmented reality, and virtualization. So I'm talking about this topic. In today's topic is point number 5. Then big data and predictive analytics. Then wireless monitoring, cloud real-time collaboration. Like 3D scanning. Again, 3D scanning is different. 3D printing is different. I will discuss this little bit in the presentation. Then we have 10 building information modeling. So 5, then 9 and 10 I will be highlighting in this presentation. So you can see that how if you see this these trends, what is going to shape the industry, and you have a lot of scope basically. You have a lot of scope when you enter into this our industry, like in the future maybe not immediately. Like this, there are many articles are there which talks about technology basically. It talks about, so this article again from McKinsey only. See the title I have kept: Future Construction Industry Job Skills. Means the future skills. Currently the skills we have, but you need to develop. If you want to settle in our industry, you need to aware of these skills. You need to develop these skills. Again, I'm not going to highlight and discuss all these points, but you can see 3D modeling is there, design simulation, then estimating, the estimation costing, estimating is there, then offset fabrication, 3D printing. So many things are there already, like already in place in the industry. So now I will start the topic. Actual topic starts from here. So it's virtual construction. Now again, if you see here, what the person is holding a mobile. He's holding a mobile, and you can see there is a plan, 3D plan over the mobile screen. So what is the meaning of this? In layman language, it is, I think, but you can actually build entire model in your mobile only. I mean, not now, but maybe another 10 years later, 10 years after. So what is I'm trying to say is virtual construction is all about building everything virtually first. You don't start the project immediately. It takes around 6 months. You start building up everything virtually. Then you go to the project. Then you call all the laborers. Then you start procuring all the materials, equipment. Then you start the project. Then no, but spend some time initially on building up everything virtually. Why? Because I will explain that later. So virtual construction is all about building up virtually. So that's what. So when you say building up virtually, it's all about interconnection of various technologies, digital technologies, like site sensors. We'll be using a lot of sensors. We'll be using equipment where there is no operator, self equipments basically. Then we'll even the deliveries also, all the delivery of materials, everything will be done automatically, taken care. Even the concrete pouring is done without an operator. It's more automation also there in this. Then skilled, obviously, so you can see on the left hand side, the labor who are, how is the labor currently. For using this technology, the labor will be holding a tab in hand and doing a lot of analysis. So you'll be more aware of the technologies, and ultimately the labor will become skilled. So when I say skilled, is not only about the how quickly you can do the work on the daily basis. The same work, same thing you're doing again. That is not the skilled one. Skilled labor is all about capturing, adopting the latest trends, latest technologies, and applying into the project. Then you can see it's called robot. So robot is again small term. Now robot is not a human robot, but it's a robot means where some of the activities can be done. What I can say, automatically, like bricklaying robots we have, then we have painting robots. So what happens to do this all these things, you need to build up virtually. You can simulate all these things. That's a virtual construction. So now you can see in this picture, it is another article by Autodesk basically. So you can see there is a picture here. So what exactly you see here is, here we have an apartment, right? We have some commercial or a mixed apartment, or it can maybe it is a residential project. So you can see it's a gray color. All the gray color is already existing in the project, existing in the on the land. Now I want to build one highway over this. I want to construct a flyover or a metro station, anything. So what I will do, I will not start the project. I will not directly go to the site and start the project and face many problems. Then I stop the work. I will not do that, because if you see in this, it's a commercial area or a area with a lot of people walking here and there, traveling and all. So you cannot start the project just like that. You need to take permission. You need to see the challenges. You need to try to do the feasibility study, many things. So virtual construction help us to build digitally before you start the project. So what you're seeing here is this all is a virtual model. It's not real model. You are placing a virtual model into the existing model, existing location in the digitally, and you're trying to do some feasibility study. You're trying to check whether it is feasible or not. So here what happens, you can change the shape of the structure, you can change the alignment, you can do many things virtually. Then you move to the site and give all the work to the contractor, and then labor will take care of that, all that automatically. We don't require. So our job is mainly this, build up, developing a model like this, and do some simulations, estimate the time, estimate the cost, check all the feasibilities, check the alignments virtually. Again, everything should be done virtually. So like I said, virtual construction is one of the major field. So when I say virtual construction, again, we have many things are there. We have software systems like BIM, then we have artificial intelligence also, then we have autonomous construction equipment. So these three basically together help us to build everything virtually. But in this presentation, I'm talking only about the BIM. I'm not talking about AI. I'm not talking about even autonomous construction equipment in this present presentation. But overall, why this is happening? Again, why all this are happening? Why these changes required? Because we have a lot of manual work is happening. We have a lot of labor, but still labors are not available now. Now earlier, 3-4 years back, it's if you talk about these technologies, people used to think about losing jobs. Now, if you see the trend after Corona, there is no labor available. Now, no labor is interested in doing these works. They want to go and join some industries, or even in malls also, in shop, they are getting at least 15 to 20,000. So why they will come and work on hot climate? So what is happening is we don't have any labor also. So you have to use this type of technologies so that you can eliminate, you can replace the most manual work in a project. Whatever the manual work is happening, you can replace. But again, you cannot just put a robots, some technology in the site and start the work. You have to plan it before. You have to pre-plan, or you have to plan the construction. So that planning is nothing but again a virtual construction. So virtual construction can be also applicable in our existing buildings also. If you see on the left hand side, there is a picture here on the left hand side. We have one residential building or some building where they want to do renovation, and you can see on the right hand side, you have 3D models. You can see 3D models are placed here. So how it is happening, because there's a technology called scan to BIM, where you go to this existing block to take the coordinates of area element. Coordinates means all the XYZ coordinates. Then you automatically build a 3D model in a Revit, Autodesk Revit. Then you start incorporating some new elements, like if you want to put a HVAC duct, you want to introduce new columns here, you want to put tiles here, you do a modification. You see you can see on the left hand side, there's one door is coming, new door, which is not there here on the left hand side. There's one opening is there maybe, but in the right hand side, they're trying to put some new door and all, whatever. So what is happening is you can also use this virtual construction concept even on the renovation projects. If you want to renovate the existing project, you go to the existing building or existing structure, you take all the coordinates. So there is again a concept called laser technology. We have laser cameras where it captures all the coordinates from every angle. Then you take the data and you can use a software called Autodesk Revit, and so automatically you can build a 3D model. Then you modify the model. Again, you go back to the site and construct that. That's all about virtual construction. So you can also apply in these renovation projects or retrofitting projects. That's what. So the same you can see on that. So what is happening here again? If the real picture, that's what I'm telling. So you build a 3D model in a tab. You just build a 3D model in some softwares. Then you bring that, you convert or you transfer into a tab like this. Sorry. Then you come to the site and you can visualize. So you can imagine, like by putting this, by positioning this tab in front of you, you can see how the future this room will look like. So what you can see here is all these colors. The door is here. We have a HVAC, some cable tray is here. On the right hand side, there is some, maybe it is a column, or maybe it can be duct. And this white color is nothing but a duct only, AC ducts, which are not there in this real model, right? It is not there. So what you're trying to do is, you're not starting a project now. You're just planning it. You're coming to the site and you just imposing this picture in this model, real model, and you're trying to see whether that's all. If it is feasible, okay, then I will start the project. Otherwise, I will not start. I will go back and I will rechange, I will modify. So I can do this several times without putting a labor in the site, without wasting any money. It will not cost much also for us. Initially, it may cost much. I mean, you have to invest much money to buy these softwares, etc., etc. But later, once you spend that, once you implement that, it will become very cheap in the later stages. That's what. Here also you can see that a person is checking the model, and there is no model actually in front of him. It's a steel structure which will come in the future. So it's a company called Unity Reflect. They actually work on a set of solutions. Everywhere, it's available in India also. The company is there in India also. So what is happening? He built a 3D model virtually in his software called Autodesk Revit or the many other softwares. Then he is coming to the site and he is checking how it will look like, if it is feasible or not. So I'll just play another video. So you can see this video now. In this video, you can see that on the person who holding a tab, right, on behind, there is no structure is there. So what he is doing is he just want to check how it will look like. So it's almost like looking like a real, right? The video, it's looking like real. There is no structure actually in front, but it shows the future, like how it will look like in the future. Basically, it's already happening. Construction is happening. You can see here, but it's a finishing structure. So you can actually, it's a very normal thing. It's mainly from architectural point of view. They want to check the aesthetics on it, but it is not about that. Many things can be done, which I will show in the next slides. So it's another virtual model again. So it is shared by James Pauls, one of my dearest friend. He's basically 4D BIM consultant in UK, basically. So he shared his video. So what you're seeing here is, again, I don't know, I think you in the 4th year should have a course called Construction Management in Entrepreneurship. There we'll be teaching CPM and PERT, critical path method. There is one technique called PERT where it helps us to schedule the project. So when you talk about any project, we have so many activities, starting with excavation, then foundation, construction, Right, for footing construction, then basement walls, retaining wall construction, then ground floor slab construction, then we have column construction, then slab construction, then you have door installation, lift installation. Like that, we will have more than 200 to 300 activities, right? Basically. So that is on the left hand side. What you see is this is what we're teaching currently. On the left hand side, there is a bar. It's called a bar chart, or it is also called a schedule. So on the right hand side, you see the model, virtual model, basically. So what is happening? You can also simulate that. So you can also simulate entire project work. So I will show how it is done, basically. This currently is not playing. I'll check later. Yeah. So I'll just play this. So see how it will look like. So you see on the right hand side, currently there is a date called June 2013. There is a one vertical line, right? So it is starting the project. So it's not a beginning of the project. It is one of the mid of the project. So currently I'm showing the simulation of shaft construction. So I'm just showing the arrow here, right? I'm highlighting here. I'm just showing the simulation of a shaft. You know what is shaft? It's a lift shaft. So I'm only simulating. I'm only showing the video of a lift shaft simulation, time simulation. So you see here now how it look like. So as what you can see is basically a simulation, basically. So you can see how it is building up. So what you're saying is you're seeing entire project construction, basically. Execution of the project. So it's a lift shaft. So they're coming step by step down. It's a top-down construction, basically underground, basically. So they're trying to build a shaft using, there is a tower crane is there. We have mobile crane is there. We have again excavator here. So they are building up slab by slab, the step by step. So you can see how detailed it is. It is called 4D modeling. It comes under BIM. So I written in the bottom 4D BIM, right? It's one of the dimensions. So I will explain what is that later. So what you're seeing in this video is, so you can also see on the left hand side, what are the activity it is there. For that activity, it is showing the virtual construction. The visualization is done for that. So what is happening by doing this? So what is the benefit? You can actually see how it goes. If any problem is there, sometimes what happens, you can check the time, how much time it is taking. So you can return here 28 days. So it is taking 28 days. So, okay, then you have to check back whether it is feasible or not. 28 days. If you don't want 28 days, you can minimize 28 days to 20 days, or you can increase the time. You can do all these scenarios before you actually start the project. So I'll just play again, just for if anyone missed out. It's only a few seconds. So you can see that what I'm trying to show is this is all about virtual construction. See the level of detail we can do it. So we have software for this. There are software which are free for the students, for the faculty, for education. There are the softwares which are commercially available. The software which I'm showing is a Synchro, Bentley. So in my university also, we have students who are working on these areas. They use free softwares from Autodesk. So Autodesk softwares, basically all which are BIM softwares, again, virtual construction softwares, they are free for students, basically. So we can actually use in our projects. So we can put in our CV, right? So you can easily apply for these type of jobs. Again, no company want us to become a skilled in this completely. They just want they want students to get aware of this and do some small project works. That's all. They will give you training later when you join in the company. But you should be aware all those things in your BTech at least. If you're more interested into this, if you want to pursue a career in this, then it's always better to do MTech in construction management. So again, there are different terminologies are there again. We have different. I'm talking about in the world. People call virtual construction as a digital twins. Digital twins means means we have one real model, one original. This one virtual model. That's a digital twin. Then some people call augmented reality. So whatever the videos, snapshots, that other one which I shown is in tab where he went to the actual location and he's checking the video, he's checking the model, right? That is called augmented reality. Some people also call virtual reality also. Again, there are now currently they call BIM. BIM is a term used for virtual construction or virtual design. So recently I also come across zero drawings construction. It's a very interesting term which I will show you later. Zero drawings construction means we don't have any, don't use any 2D drawings, no AutoCAD drawings, no physical paper holding in our in the hand, no 2D drawings. everything is 3D models. You hold a tab with you, go to the site, zoom the 3D models, you change the location, you can visualize any angle and communicate with the labor and start the working. So there is a one project is there in Norway where they executed currently executing the one basically one highway one overhead highway project without any drawings. So it is called zero drawings construction. So there are different terminologies. And in India, most people are calling now again digital construction also. Then we have also construction industry 4.0. We have already industry 4.0. So industry 4.0 is all about this one, kind of automation. Then we have connectivity basically using Wi-Fi technologies, all the IoTs. So these are the various terms. Again, still we have many other terms, but I have used here which are most frequently used. But they all come under one platform, virtual construction. They all come under building up everything virtually before you start the project. That's all about that. So if you have any doubts also, you can ask me in between also. You can stop me anytime. So if I define what is VC in short form, virtual construction, or it is also called as VDC. VDC is virtual design and construction. Or in short, VC is virtual construction. So according to the BCA, Building Construction Authority, Singapore. So VC is management of BIM models as well as people and processes in order to achieve explicit project or organizational goals and to improve the performance. So in essence, VDC is to build twice, first virtual, then real. So that's what I'm trying to say from the beginning, right? You see on the left-hand side, it's a virtual model. First you build virtual model, you do all the simulations, you do everything, not only design again. So what you're seeing here in this all may look like architectural design. It's not that. You can do architectural design, then you have to do structural analysis, then you can do time estimation, cost estimation, life cycle cost estimation. You can change the materials and try to calculate the carbon dioxide emissions. You can virtually do many type of analysis. Then you start build this real one. So VDC is, in short, it is built twice in short form. First virtual, then real. So build twice enables a project team to fully simulate design and construction in a virtual environment. First, prior to actual execution on the site. That's what I'm trying to say from the beginning, right? So I'll read again. So building twice enables a project team to fully simulate design and construction in a virtual environment. First you do that prior to the actual execution of the site. So prior to the actual project starting, actual execution, you start building everything virtually and simulate and check the data, how it works. And you will find a lot of issues, not one or two issues. You have too many issues you will be facing, which can be minimized virtually without spending a lot of money. Once all the problems are resolved, then you can go to the site and actually start the project. You may get some other issues like rains and the COVID and all. Those cannot be, those external reasons, external causes cannot be managed with virtual construction, but internal issues can be done. So this is all about basically VC. And I was telling that it's all, I'm talking about awareness in India again. So you see the articles, some news articles are there. There are just a sample I kept. All these articles are Indian, they are written by Indian companies and articles again. It's for Indian basically, not for other countries. So mainly the articles came with Hindu, right? You see that it's not written here probably, but the articles are taken up from Hindu, Times of India, India Today, some other technical article called Geospatial World. They are all from Indian articles. See that terminology, digital twins in demand. Means there is a skill requirement is there. There is a what we're trying to say is students has to aware of this type of technologies and try to acquire during their education. Then power of augmented reality in construction. Then improved design and construction of New Delhi International Convention Center through BIM. I think recently you know this New Delhi International Convention Center. So entire project they have executed using BIM. It's basically Tata Projects is there. Tata Projects and Shapoorji Pallonji they have executed entire project using BIM. So who is actually done this entire work in the Tata Projects company? Then we have Shapoorji Pallonji Limited company. So the engineers who working in the company they have only done all those things, right? I mean they are not. So no one. These companies never hired any abroad or consultants. It's all done by our Indian engineers only, who capable, who learn, who acquire these BIM skills. So this article also, these articles, we have several articles. Again, you just type all these keywords in Google, type India and type the year, current year, you will get huge number of articles, especially India only. No, not only that, even Bangalore also, Bangalore International Airport, we have completed the terminal 2 entirely executed using help of BIM. And there are many projects we have currently. Even now, what they say is in every project now, we have a contract documents. Before you start the project, there is a contract given to the contractor. So in the contract document also, they added one clause that the engineers from that construction company should have a skills in handling the BIM models. So that's the thing. So there is a requirement given in the contract also. Now every company wants at least few engineers to acquire this type of skills so that it will help the company to reach to the next level. So when I say again, like I said, right? So all this I think now it is clear. Like so, when you want to acquire these skills and if you want to work in this area, it's again a office jobs again. It's not like you obviously have to go to the site and check the problems, do that. But it's not like you have to stay in site and execute the project. You will have to be doing a lot of analysis on the back end basically. So that's what this is the first part. This is the first part of the presentation, or 1/3 of the presentation, which is virtual construction. It's a theory. I talk about the concept, idea of virtual construction. Now the question is how it can be implemented. The question is that all right? Mainly how to learn this or how to implement this. What all softwares are there? Like how to do that, how to build, how to learn that. So we have a term called BIM. It's called Building Information Modeling, which you can see that what this thing. It is a cycle basically, life cycle of a project. Generally, what happens if you talk about a project? Generally, you start with some programming. Programming means planning, scheduling. You have to do some plans, make a rough sketches of the project. You go to the site, you do feasibility study. Then you develop a conceptual design. You develop a concept of an entire structure, like a look of the structure basically, aesthetical or architectural project. Then you will be doing this one, detailed design. Detailed design means structural analysis. You might have learned STAD and all that, ETAB, STAD. Then estimation costing will be doing. So you will do a lot of analysis here. All the structural analysis, some cost analysis they will do. Then you will prepare all the drawings in the project. Once you complete all the design part, then you start detailing. You will develop all the drawings. You will develop at least more than 300 to 500 drawings in a project. Then after that, fabrication will start. Once the drawings are ready, then some of the drawings will go to the shop drawings. We call it shop drawings. They will go to the fabricators. Any structure is there where you want to fabricate outside of the project, those drawings will go to the fabrication. Then project will start. Your construction will start. In construction, you will be basically you will be focusing more into the time and cost. How much time it will take? How much money I need to spend for labor, for the materials, for the equipment? You will doing a lot of optimization. You will try to minimize the time. You will try to minimize the cost. So you will do all the things in construction. So here actually you will build the structure. Again, to do this, you require a lot of logistics. You have required tower cranes, you require equipments, you required site offices, required accommodation, temporary accommodation for the laborers in the site. So you need to do a lot of logistics planning also. So once you complete a project, then you will have operation and maintenance, right? Once you complete a project, then you have to also maintain the building. You cannot just give the project and leave it. There will be another contractor who is going to work in this building, and he will be taking care of the operation of the building, maintenance of the building. Like in apartments also, we will be having some operators.
Design the slab for a room of internal dimension 4 meter into 5 meter. The slab has two adjacent edges discontinuous.
Oh, someone is talking. Hello.
Consider live load is 3 kilonewton, floor finish is
Kajal?
1 kilo.
Madam Kajal, please mute it. Yeah.
Yeah, fine. So yeah, so operation maintenance happens. So again, once you complete operation and maintenance of the building, then some of the buildings gets very old, then they will go demolition. We know that there are a lot of buildings currently we have in Bangalore only, Karnataka only. They are demolition because they are very too old to renovate. We cannot renovate retrofit the buildings. But there are some structures which can be renovated. Maybe not during end of the life cycle, but in the middle of the life cycle also we can renovate. So again, for renovation, again you have to bring some resources. You require labor, equipments, and all. So what I'm trying to say, this entire life cycle, which is there already in a project, everyone knows about this. But when you say BIM is all about visualizing the entire life cycle. Now, life cycle, which you can imagine, entire all this can be done virtually in a one platform, and you can visualize everything now only. Like before you start the project, you can visualize the renovation also. You can try to renovate the project here only without actually going to the site. So you can do everything. So what you're seeing is everything is a 3D model here. Everything, whatever you're seeing, everything can be visualized in 3D platform. Then you have another dimensions like 4D, 5D. You can see it is written in the here. Construction under this, the term called 4D, 4 dimension, and 5 dimension. So I will explain what is the dimension. So what is happening is everything can be done basically here. Idea is that everything can be done in a virtual platform. So that's a building information modeling. In basically, it's in layman language, it's a visualization of the all the stages of the project. That's called BIM. So again, so that's what they say. No, that's what. No, you see that previously I told you, virtual construction is all about building twice. Now BIM says that you build it twice but cheaper. That's the output you get from this BIM, building information modeling, or output you get from virtual construction. It's not so. A question will arise again: why to build twice? Why to spend this much money in this all these things? Why to develop softwares? Why to buy the softwares? Why to buy the systems? No, why to waste a lot of money in this all these things? What is use? The ultimate benefit of this technology called BIM or virtual construction is finally we can build cheaper. Means we try to save the money by doing this. We'll try to analyze what are the areas where I can minimize the money, which I cannot do in real project. When I start the project directly, I cannot get time to do that all this. So the BIM is all about that. You build it twice, but build it cheaper. Finally, you can minimize the time, you can reduce the time of the project, and minimize or reduce the cost of the project. That's the ultimate goal of a virtual construction again. Then only people invest, right? If you tell that if I want to start this technology, who will listen? No one will listen unless you show the benefits. So L&T, so L&T construction again, L&T construction says that BIM is a new construction language. So there is a lot of requirement is there in L&T also. We have people actually in HQ. If you want to go in a head office in Tamil Nadu also, there is a separate department who are actually working currently in this area currently now. So they're calling as a new construction language, BIM, because it is a universal solution for all the design and construction problems. So it can resolve all these issues. That's the reason. That's what benefits. So if when you are actually implementing this virtual construction concept using BIM, we have several benefits. It's Autodesk company again. They after implementing, they found these benefits. You can minimize, you can reduce 33% of a project time. You can minimize 33% of a cost. You can also minimize a lot of rework. So many things will happen, like doors, once fixed, they have to refix sometimes. They don't properly fix the elements. Sometimes you will do a lot of mistakes in the design itself. Sometimes which design can get wrong. Sometimes the project layout, site layout will get messed up, like with so many equipment and all. So you will do a lot of rework in the project. That can be minimized with 36%. 45% can be increased. Labor productivity or labor performance can be increased by 43% because they will not do everything manually. They will be having some tools with them. And this is very important, right? Nowadays, greenhouse emissions, CO2 emissions has to be minimized. So that also will be done. So that is another indirect benefit of a BIM. Indirect benefit of virtual construction. You can also minimize carbon dioxide emissions by selecting the right materials and visualize them before you start the project. Then ultimately 64% will be there, 64% savings will be there in minimizing the document errors and emissions. Since currently we use 2D drawings, we will make a lot of mistakes. So develop a 3D models, we can visualize everything properly, like junctions and all, especially in the buildings. And for example, you can visualize everything. But if you depend on 2D drawings, two-dimensional drawings, which are coming from AutoCAD, what happens is you do a lot of errors. But I'm not saying that we should not work on 2D drawings. 2D drawings are required even now also. But we should not depend on 2D drawings to build a project. We should use 2D drawings for many other purposes, but we should use 3D models basically to execute a project for better accuracy. So in BIM, what happens? We have several dimensions. We have dimensions like D, capital D. So you can see here. First is a 3D. It is called visualization. Represent the building in 3D basically. 3D is everyone knows 3D. What is there? Even in AutoCAD also we can have this isometric views and all, right? 3D model can be done, but that is different. In AutoCAD we develop line diagrams, line models. We do have not models also. It's line diagrams basically. Whereas in Autodesk Revit, if you go into the Revit model, Revit softwares, you can develop a 3D model. So 3D is that. BIM starts with 3D basically. Then you have 4D, 4 dimension. It is nothing but time. Then we have 5 dimension, 5D, which is nothing but a cost. Cost of the project. I think you might have learned already 5D in your estimation and costing course, where we teach how to take out the quantities, then how to do the rate analysis, then multiply with quantity into rate, you get cost. That is 5D. Then 6D is operation. Operation is all about facility management. After completing a project, you need to maintain the building, right? You will have a lot of things to maintain. You have to check. You will get a lot of repairs in a building. You need to do servicing and all. For the if it is commercial projects, you have to do a lot of service in AC, air conditioning. You will have a lot of false ceiling. Under that false ceiling, you will have plumbing, electrical, everything, right? All the lines will go in the ceiling under the slab. So you have to do a lot of maintenance. So that was there. That is called nothing but 6D. Then 7D is sustainability. So sustainability is all about it. We know the carbon dioxide emissions, right? Reusing the waste materials in a project and all. So there also BIM can help. Then 8D is quite new area. It comes under safety, immediate emergency plans, prevent security issues, more into the building safety basically, which we're not working on that. So these are the 6 dimensions currently have. Even we have 9, 10D also, but currently industry is more interested in 3D, 4D, and 5D only 3 dimensions currently in the industry. They want students to acquire skills, to develop skills in these 3 dimensions currently. It's enough if they can develop these skills as of now. So that's what. So again, same thing. So if 3D, so what is happening is when I say 3D is 3D model, but when I say 4D and 5D, 4D is nothing but again a 3D model with a time dimension. You added time to the 3D model, it becomes a 4D. So you can see that same model is there on the central part, the figure. The model is incomplete, means it's simulating. It is slowly coming up. That's a 4D. Means a 4D focus on time, the execution of a project. Now 5D is all about cost. You can see all the various graphs you can plot. You can find out what are the elements, which element is costly, what is the labor cost as on today, what is my material cost as on today in the project basically. In the beginning of the project, even in the middle of the project, even the end of the project, you can always check what is happening in the project, how much money I spent, how much time it already went. Now COVID came, 3 months work is stopped. So how to minimize that? How to come with how to manage that 3 months delay? What is the change in the cost? Suddenly a tax is changed. Some GST tax, some taxation, some budget has changed the taxation and all, right? So that also will affect the project cost. So you can do all this costing analysis in the 3D model. So what is happening is all these dimensions are working on 3D model again. 3D model is a central platform for all the dimensions. So without 3D model, you cannot do anything. You should have 3D model first. From 3D information model only, you can do the time analysis, you can do the scheduling, costing, simulation, energy analysis, safety analysis, quality checks, everything can be done. So when it comes to visualization, when I say BIM can help us to develop a model like this. So it's what you're seeing is a one factory, right? With a complex, huge complex elements are there here. We have, it's nothing but a MEP model, mechanical, electrical, plumbing model. You will see a lot of pipes, a lot of channels are there. This square channels, C-section channels, a lot of section channels are there. Then you have even some cylinders, whatever it is. As per the requirement, they build a 3D model. So you can visualize this model. So before you start the project only, you can build this and you change it. You can change. Another advantage is you can change this location, this pipe to another location. You see how what happens. You remove this column, you put another column here, you put one pipe here. You can do many changes here only without going to the actual project, which cannot be done, which will cost you huge. So another main benefit of BIM is you can also identify the errors like clashes. So what is happening, you can see that there are 2 elements which are crossing each other, which is not possible. But eventually you can identify these errors and you go to the site and you can change it. But if you don't use this technology, what happens in the site, you will find this issue in the site only, in the middle of the project. Then what you have to do is you have to stop the work. You have to tell again to redesign the building. You have to ask the designer to submit the new drawings. So at least 15 days will go into that only. So whereas in this BIM platform, you can actually identify these errors. So that's the main thing. Visual construction is all about identifying the all possible errors before you start the project so that you can resolve it. Then you start the project without any error. You can see in the bottom also there is a channel. Maybe it is a rectangular duct, air conditioned duct, and there is a fryer. It is written already, HVAC duct work. The duct is there passing like this, and there is another model called fire sprinkler line, which is passing through this, which is not possible, right? So why this is happening? Because In industry, we have fire engineers separate, electrical engineers, mechanical engineers, civil engineers, structural designers, architects. Everyone is using different drawings, different models. So when you put all together, then you will find these issues. So this can be done basically. That's all. So you can see these are the vacancies, conflicts, clashes happening. You can see that the drawings. There are two drawings over there on top. On the left-hand side, what you're seeing is there are 2-3 elements which are clashing each other. Now what you will do is you will change it. You come to this level. Now you can see this figure. You will not find any element touching each other, clashing. So you can do this virtually, right? It will not cost you anything. There is no labor involved. There is no crane required. There is nothing is required. It's all done virtually here. But if you identify this mistake in the project, then what will happen? You have to stop the project. All the equipments will get idle. You will lose a lot of money. So these things can be minimized. All the clashes between the models, all the clashes between the components in the building can be resolved before you start the project. Similarly, you can see on the bottom also. You have some elements like plumbing pipeline, electrical pipelines. So you can see multiple clashes are happening. On the right hand side, you will find that it can be resolved. Then you start the project. Then you inform to all the engineers and all. Then you can start the work. Some more pictures. You can see the left hand side again. You see it's very complex. Basically, all this will happen in the commercial buildings like hospitals, metro projects, shopping malls. There only you will find in the ceiling level or in the basement. You go there, you will find a lot of issues. So all this can be resolved using technology like BIM. You can see on the bottom also how it looks. You can see very clearly the left hand side, the picture, and the right hand side how it looks. What is the difference between these two? It's very clear now. There is no clash. The elements are very passing near to, but they are not hitting each other. These type of mistakes will happen in a project, which can delay the project, which can affect the project drastically. So when you talk about softwares, so generally it's all be done in software. So when I say virtual construction, BIM and all, even Excel is also a virtual construction software. Interestingly, because that's what virtual construction, you can see there's several softwares are there, which all come under Autodesk. Basically, it's Autodesk softwares. You will find cost management softwares, design checking softwares, bid management, tendering softwares, scheduling software, estimation and costing. You learn already in the course. Then layout softwares, preparing layouts, site layouts, document management, mixed reality, plan grid. There are several softwares are there. I'm not trying here you to learn all these things. You don't have to learn anything in this. You have to choose one area and you have to learn in that. Then develop a skill in that. You cannot apply a job. You cannot say that I know everything, right? You have to choose some specific area and focus on that area. Now you see this, there are several softwares are there. You see on the right hand side, there is a Dropbox. Currently everyone uses Google Drive, Dropbox, Excel, right? So these all also comes under a virtual construction software because these actually act as a support to store the data, to use the data. So all the BIM models, what you're seeing here, it has a lot of information behind. For example, I want to know the list of components. In Excel, I want to know the list of components with the specification. I want to know the dimension of all the components in the table format. So I can actually capture from the 3D model into the Excel. So there is, for that, we have a plugin in the Revit software called Dynamo. I will show you later. So you can do all those things basically. So that's why Excel, OneDrive, all this connectivity softwares on the basic documented software also comes under this virtual construction domain. So you can see this, how many softwares are there? Like too many softwares like that, where you can learn. Few you can learn on your own freely. You can actually download the softwares. You should have only this student ID card. I will show you later how it to be done. You can do all those things. You can learn on your own. There are online courses we have for that, where you can learn and where you can use it in your CV also. You can start applying jobs also. It can be done within 6 months. You can learn many things. Whatever I shown to you, everything can be done in 6 months, total 6 months. And you can apply this knowledge in your project works also in 8th semester, in BTech or if in MTech in the second year. If you have mini project, you have seminars also in your curriculum, right? You can study these techniques and explore. So you can learn all these things. At least 50% you can learn on your own only. That's what industry wants. Industry doesn't want you to learn everything and become an expert and you apply job. They will train you later, but you should have some basic idea of all this, not software, but all this entire concept. So I'll just show you some. So what I'll show some examples I'm showing here. I'm not going too much technicalities into this presentation because you cannot follow just in 1.5 hours. It's very difficult. I just want to put more pictures and make you active, interesting. So this I was telling, right? There is a concept called zero drawing construction. So in this project, it's a Norway. There is a Ranselva Bridge project in Norway. It's one of the world's longest bridge of 634 meter. Entirely, this project is made on BIM models. There is no drawing. They did not use in 2D drawings. Entirely, they built a 3D model. Using the 3D model, they executed the project. It's ongoing project actually. So you can visualize many things. You can also visualize the reinforcement details inside the model. You can see the spacing. If you zoom it in the model, you can zoom in. You can check the spacing between the reinforcement. If anything is issue is there, you can change the spacing of the reinforcement. So you can come to the site and put this entire pier, and you can check how it looks like. So entirely this project is actually ongoing project. It's completely done on BIM models. So this is how it looks. So it is a 6 months old picture. Currently also you will not see much changes, but this is currently the status of the project. Now what is happening? You can see that the project is in beginning of the stage. You can see only piers, pier cap, pile foundations, pier cap, piers, everything is there, right? They are just not yet started completely. I mean, they are still in the substructure or just part of the superstructure. But before they are in the beginning of the project, right? But still they have done everything. All the project is complete already. They did even simulation of traffic also. So you can also do that also, traffic simulations, where you can run the vehicles, which actual load of the vehicles, you can simulate it, you can scale down, and you can see the traffic load on the bridge. You can also verify the vibrations, whether the building will be safe or not. You can also monitor the structure. Structural health monitoring can be done. Basically. This is the actual status. Again, India. If you talk about India, it's already there in the companies. It's already implemented. 3D, 4D, 5D is already taking place in the company in more details. So these are some of the projects. There are so many projects are there, not just one and two, not only these things, but you will find personal rapid transit system in Amritsar, entirely executed in BIM, BIM International Airport, Nagpur Metro Rail Corporation, Delhi Metro Rail Project, then Agra Kanpur Metro Rail Project, renovation of Central India's Gwalior Railway Station, and all the commercial projects like hospital, shopping malls, IT complexes, they all built in using BIM. These are the real projects which are already executed in India. So just think about those people who are actually working in this job roles. They are basically nothing but BIM engineers. Some of these 3D visualizations, that's all. These just projects which are executed using BIM models. So when you see pictures, it's not again architectural thing. That's what I'm trying to say. It's not about aesthetics and all. Just to build a 3D model and leave it. You're actually BIM or virtual construction starts from the 4D, time and cost. You see Nagpur metro station. So this is how they made the model. First they presented this model to the client. Once the model is approved, then they started simulating the time and cost. See the level of detail in this. With foundation, including foundation, you can see on the right hand side how the details are there. And it is done. One more thing is very important. I want to say this model, whatever you seeing all this, it is done by more than 20 to 30 engineers. Everyone will get some task. Like I'm architect, so I will develop architectural 3D model myself. Then structural engineer will develop a structural 3D model. Then construction engineers develop their construction models. Mechanical, electrical, plumbing, everyone will develop their own models. You will have more than 7 to 8 models. Then those models are put together, integrated using a Navisworks software. There is software called Navisworks, which is also come under Autodesk platform. It's also free to download for students. I will show the softwares, these particular softwares I will show. So this is all about introduction on virtual construction. So, but in the short time, I cannot really explain much technical details in this. So now what I'll do, I will just show some of the details of projects, virtual construction projects executed in our university. So in MTech level, in BTech level also, there are students who are working in these BIM projects. So I'll just show the details of those projects. This is one of the BTech projects where he actually applied 3D, 4D, 5D, all the 3 dimensions for a residential apartment. So you can see the software called Revit. It's a Revit software. His name is Krishna Gowda. He's one student. He's currently working in Atkins. So he got a job. It's not a campus, but he applied in Atkins. He got a job as BIM training. I think within 2 months he will be permanent. He will get his probation will be over. He will become a BIM engineer. But currently he's working in Atkins in Bangalore. So one of the project. So another project is also executed by BTech people only, built 8-semester projects. It's basically they did a 3D model of a shopping mall. They proposed a new shopping complex. Again, there are so many things are there which I'm not showing. It's not only just architectural plan. Inside MEP, electrical, plumbing, time, cost, everything they executed. So this is just for advertisement. They also build some creativity they have showed here. You can see the level of detail required for this. This entire model is done in a very detailed manner. It takes a lot of time also. It's another project. It's done by this Kaushik student. Is in MTech CM project, MTech Construction Management second year project. So here what is done? He actually done a 4D5D. It's a hospital project. So what he done is there's a project in Andhra Pradesh which is already completed. Then he went to that project. He used all the 2D drawings. Then he built a 3D model. He compared the benefits of the build model. You can see in the bottom there is a model is there. Then there is a project schedule. It is called Gantt chart, bar chart, or a CPM network. It's the timeline basically. Times are given for each activity. There is a starting time given, end time is given, and simulation is done. Then we have commercial office building. See, you can see on the left hand side there is a right hand side. So what is happening? So here what is happening is in BIM. Once you develop 3D model, 2D plans can be done generated automatically. You don't have to develop a 2D plan here. Maybe I should show in reverse way. I have to show for 3D model, then I have to show 2D plan on the right hand side. So this 3D plan, first you develop, then we develop a 2D plan out of that, basically. So what is so here I will show more details. It's MTech project. So what you're seeing is first one is architectural model. This is a structural plan model. A structural plan model. You can see footings also there. It's only one basement structure, and we have footings here, isolated footings. Then we have structural columns. It's like a normal movement resist frame structure. We don't have a shear walls here. Then you have a lift room. Now you see the what I'm trying to say. See what you see on the this one. This is a heating, ventilation, air conditioning of that project required. You see every floor this is given here. Maybe I will zoom out. Maybe it is not like clear. You will see all the ducts are there. All the ducts. You can see how much detail is required in this. You require a lot of effort initially in this area. Basically, it's not easy. But once you develop this model, you can reuse it again for many projects. That's the best part of this. You have to just change the dimensions, but you can use the model many times. So once the 3D model is built, he had developed a 2D plan automatically. That's the thing. So used. So what is happening? This is not taught much. We have a building services course in MTech Construction Management, but I did not cover much into this. We have an introduction course, but he learned himself and came with this project. This is again a fire plan. You know what is a fire plan? Fire lines. From you can see the reservoir also, fire tank also there, underground fire tank, which carries a water for that. Then have a 3D view of electrical layout. Electrical is more complex. You can see the connections how it is given. So I cannot show the visualize. I cannot then zoom it. It's not that clear, but you can understand. So what is happening is each model is done separately. Then all the models are put together. Then identify the clashes. Those clashes are resolved. And this is a plumbing layout. Plumbing again. Plumbing also only for bathrooms again. Some bathroom only for this one. Wastewater basically, not the drinking one. Only wastewater drainage plants. So what you can see this model. What you're seeing is the left hand side integrated model. It's all electrical, plumbing, everything is put together. Then all the issues are resolved. Then the simulation is done. Time and cost simulation is done. Like I told it, you can identify a lot of issues. You see on the left hand side the level of detail. There is some mechanical, electrical, plumbing elements are there. You see this one, this pipe. It is hitting the wall. Now this detail is 3D. This 3D model is different, and this structural model is different. If you remember, I have shown models separately. Structural model I have shown separately. Now you can see in the structural model, we have all the MEP electrical details, electrical, mechanical, plumbing details also embedded. So in this, what is happening is 4 or 5 models are put together now. Previously, what is happening is all are independent. You see structural model how it looks. It's only structural details. We don't have any plumbing line, electric line passing in this model. We don't have any details. Once I develop all the models independently, then I integrate it together. So what is happening is there is a pipeline hitting the wall. Once you integrate the model, then you realize this. Then you see on the right hand side, there is nothing is there like that. We don't have any integration. So what is happening in this model, there is a wall removed completely. We removed the wall here because we cannot change the location, though they have removed the wall. So like that, there are several changes can be made in this model. So what is happening is in this model, you can change everything can be changed before you start the project. In the actual project, if you do these changes, it will be a costly rework. So more pictures. You see here also, there is a pipeline again hitting the wall, structural wall. So what they done, they removed this wall basically. Again, when I say remove is not simply removing, again, you have to check the structural design aspect also. But all these changes can be done virtually here without going to the project site. Now just imagine if you want to remove this wall in real site, really in the project, if you find this mistake, then you have to demolish the wall, you have to break the wall. Again, you have to put some labor for that, you have to clean that, again, you have to reconstruct. A lot of money, you will lose it. So you can manage this with virtually without spending any money. So this what happens is when you identify any mistakes like this, clashes are then. So one pipeline is hitting the wall. So on left hand side, it will show the details. Interestingly, it will show the many things. It will show the details of clashes between the architectural, structural, architectural, electrical, structural, electrical, plumbing, electrical. You know, it will also tell from which area, which domain it is. So all this analysis will be done again. So like I said, in modeling all this, what I'm explaining, it's not only just modeling. You will do a lot of analysis behind this. So this is another one. So this is our project only. It's done by another student. So what you're seeing in this, you can see on the left hand side on the screen, where you will see the time and cost simulated. It's 4D and 5D. I'll just play it. You can just go through this. So it shows it's actually a project, one of the Bengaluru project only. So you can see how it is simulated. So what you're seeing is the project execution is simulated. So more than that, that is okay, but it's not important. Simulation or animation or it may look good, but see on the left hand side, the best part is at each stage it is showing what is the material cost, what is labor cost, what is my equipment cost on each stage. If I pause it anytime, let's say I just did pause, I stopped the simulation. At this stage, maybe it is in second floor, I think, I can see how much money I had to spend, how much labor money, how much equipment cost I need to spend in the future. So it will tell at stage wise how much time, how much cost I need to spend. It will also show the percentages, how much work is already over. So right now it shows that 43% of work is already done. So you can see many things can be done. You have to do a lot of work behind this. Again, it's the output basically. You have to do some scheduling analysis, cost analysis to be done. That has to be loaded in this model. So you can see you can turn the model anywhere. You can stop the model. You can go inside the model. You can do walkthrough also. The best part is the walkthrough can be done, where it will take you inside the model. You can check everything visually. So you can, what is happening, entire simulation is done. So what you're seeing is from outside, right? You're seeing the structural building. You're not seeing the mechanical, electrical, plumbing services, how it will be installed. It can be done once you go inside, you can see that. But so that's for that purpose, what I've done is I have hidden the structural elements, and I will play again. So what I've done is I hide the structural elements. So what you're seeing now in this video is only the electrical, mechanical, plumbing details. Again, this timeline is done very short. Basically, its entire simulation is for more than 600 days. So if I play in real time, it will take 600 days. So that can be done, right? So I just doing it fast. The interval I made it very small so that you can see. So what is happening in the same project only, you will see the lot of details which are happening simulated. This entire project is executed. So you can stop at any time. You can go inside and you can change how it is done, how it is installed, and you can check on the left hand side the time, how much money I had to spend, how much time I need to take for this. If it is costing more, then you can change the materials and minimize the cost. Again, you simulate and check. So many things can be done basically. These are the softwares basically used by students. They used Excel first because everything starts from Excel only, and everything ends in the Excel. So when I say time and cost, it's all data, right? Even not only time and cost, quantities of the materials, design details, load informations, any other information, everything is stored in Excel only. So you required Excel in the beginning, you required Excel in the end. But you see the softwares here I written here. So basically for these projects, they have used Autodesk Revit. So the Autodesk I am showing here is, there are many other companies are there, but if you want to use Autodesk, it is free. Other company softwares, they are not free. So we have Autodesk Revit, which help us to build 3D models. Then you have Autodesk Navisworks, which help us to do all the 4D and 5D, clash detection, scheduling, simulation, quantity takeoff, costing, everything can be done in Autodesk Navisworks. Then you have another one called Microsoft Project. Like if you're doing a course in construction management in your 8th semester elective, there we will teach this software basically. It's 2D scheduling again. It's not a visualized scheduling, only bars will come, bar charts. But you can develop everything in this, and you can import in Navisworks, you can integrate with 3D model, then develop this simulation. And you can also do some coding here. Interestingly, you can also do coding work in this visual construction. Now, coding can be done using a plugin. It is there, plugin is there in a Revit. It is called Dynamo. So what happens? You have to repeat the task. For example, I want to model door in a ground floor. Now I'll move to the second floor. Again, I have to copy paste, right? I have to copy paste repetitive tasks I have to do in the Revit software. So those can be automated in one click using Dynamo soft plugin. But you have to do some visual coding here. When I say coding, it is not C++, Python, anything. It's a different thing. It's a model-based coding, which I will show with some snapshots. So these things which students are using in our university who executed these works. And this particular slide, it is already published in one of the journal also recently. If required, you can email to me, I can share to you. So this is a Dynamo, what you're seeing. It's a visual model coding or model-based visual coding. So what you're seeing is there's some of the scripts. There's nothing but visual scripts are there, which help us to do some customized tasks. Let's say I want to know the quantity of some column. I want to know the volume of the columns. I want to know the perimeter of the building. I want to know the height of the building, or I want to know how many doors are there in a building, or I want to know doors with the different sizes. So you want to know, take out the quantities basically. So you can, for that you can use with the visual scripts. So you need to, what is happening in this is you need to connect various things. You need to connect with the model. The model will be linked with some dimensions, required dimensions. Like if you want to know the dimension, length dimension, you have to tag with that. So everything is inbuilt only. You have to just know how to put together. So all this can be learned again on your own using some online courses, which I will discuss. So Dynamo is a plugin. So what you're saying is these are the screenshots coming out of the Dynamo plugin, which is there in Revit already, which is free again to explore. So what is happening for each room in a building, like you can see washroom dimension, lobby, security room. For each room, you can do some scripts which are customized as per our requirements. Because everything cannot be given in the software. You have to do some modifications. Then you can see another one. You can see this one. So this wall is created. Now you can see on the right hand side, the one wall is there. One wall is created. How? With a script. It is not done. This model is not done using directly manually. Using script, it is created this wall. You can create this wall some 1,000 times. So what is happening is no need to again select the elements in the software and build this model with a dimension done. You can automatically develop these walls so many times using the script. Here is an interesting case. This is very complex. So many scripts are used to develop a 3D model out of a 2D plan. It's even more complex one. It's actually PG works, PG, post graduation, MTech student works. It takes a lot of time. For each room, they develop a lot of scripts. And finally, using the scripts, they build a 3D model. I mean, you don't have to do manually. You can automate it. Entire model can be developed just like that from 2D plan using these Dynamo scripts. It's nothing but a model-based visual coding, but not like I told. It's not a C++ or Python type of coding. It's a different thing, which can be done at BTech level also. So same software. You can see MATLAB also use softwares for any complex calculations like optimizations, any other things. I will not discuss now. So even our students also worked in some developing some prototypes. And so they used first for that what they did. So to develop a prototype, they again did virtually. They developed a prototype software. Then they actually fabricated. It's one of the group project. So then virtually first they finalized all the elements. Then they worked on this. It's another project, very interesting project. It's very complex also, where you can see that the volumes are extracted from the building. The student want to optimize the volumes in the building. So instead of 2D layouts, instead of optimizing the layout of the building, floor layouts and all, You want to extract the volumes and rearrange it and see that you can get the best out of it. It's very complex again. Again, the same softwares, the Revit, Navisworks, Dynamo, same softwares are used for all these things. So you can do a lot of customization here. You see how see the level of detail exactly done in these models. With so much clarity, he built this. It took a lot of time, but once this model is developed, you can do many things. You can reuse these models for many other projects. So you also use again same thing. So you can use the Revit software, Autodesk Revit, the Dynamo software. Then Excel is also used. Then there's another software, not software, but it's a energy analysis plugin in the BIM. It's a cloud-based software where you can use import all the data and do energy analysis. Same picture with a different. So like I told you, it's one of the internship work. So MTech students, 2 students actually went to the internship work. So here what is happening is they learn how to develop a 3D models from existing projects. Like I told, right? If you see on the top, it's an image taken from the existing building. From that image, they have developed a 3D model. It's an existing building. Once they develop a 3D model, then you can modify it and go back to the existing building and do renovation. So see on the left-hand side, right-hand side, sorry, angles, the angles where the image is taken. So there's a software, sorry, there's a technology they have called laser technology. The company has that. We cannot buy, it's very costly. So they have used the software and build the 3D models from existing. So with different locations again. See the different locations. You can see on the right-hand side, right top corner. From different angles, the pictures are taken. Only pictures, not these DSLR pictures, but pictures with all the 3D coordinates, three coordinates, X and Y, X, Y, Z. From different angles, the pictures are taken. From that, 3D model is developed. You can see the image, how the image is looking on the top, and how the 3D model is, virtual model is looking at the bottom, the clarity. So this is a technology used for renovating the office buildings. You can see there many things are there like this. So again, this is a very new thing. Even I'm also not starting exploring still. So what they say is that all these virtual construction models, BIM, building information models, all these can become a support for your data science, machine learning, AI, and all. Because AI, artificial intelligence data is all or nothing but they depend on past data, right? They depend on the previous data. So require a lot of data to study, to predict. So these building information models, if you are implementing, then you can reuse the data to predict various things. I think time up, 1.5 hours. So I just conclude very soon. Within 2-3 minutes, I will conclude. So like these are some other. So I given the URL also, bigdataconstruction.com, and also taken from there. So what they show is that there are various software like Dynamo, Revit. Again, same software on Revit, Navisworks, Dynamo. It can be used with along with the data science software like database software like Monday, this Asana, GAN Pro, for prediction purpose. It's very advanced. Even I am also exploring still. These are connections between the software. So if you want to go further with AI machine learning, you can use Python. You can also link a Python. You can also develop Python scripts for a BIM models. Then use the Dynamo scripts for many other purpose. You can link with the Navisworks softwares. So like these are softwares you can actually learn on your own. Autodesk Revit and Autodesk Navisworks. It is free to download. You can learn on your own. You can actually do this. So this is what industry wants. They want you at least to, in this area, you want to pursue career. They want you to at least learn how to estimate time and cost, how to schedule the project, how to plan the project using these softwares. So this is what I was telling in the beginning that I told you, right? You can learn on your own. And Coursera, everyone knows. You go to the Coursera website, you just type search, you just search BIM. Then you will get 2 softwares, 2 courses. One is BIM Fundamental, and we have another one called BIM Application. And they are free. You can see it is free to learn. If you want certificate, then you have to submit assignments. There is no exam, but you have to submit. You have to prepare a 3D model. They will give some homework. You have to build all the 3D models. They have to send the screenshots to them. Then you will get certificate also, where you can put in your resume. You will be certified basically. So you can learn these 2 courses. There are 2 courses: BIM Fundamental, which they talk about 3D modeling. Then another course called BIM Application, where you can learn 4D and 5D. You can learn freely now only. You can start and learn. And there's another course I written here, construction management, also very important. If the course is already there in your BTech elective, fine. If it is not there, it's always good to study construction management courses also. It's only one course I have given because So all the softwares you cannot really become expert in by just by learning software. You have to learn a theory behind, right? You should know what is scheduling. There is a critical path method. There are some methods are there. Critical path method, PERT method, estimation costing also have some methods, right? You have to learn some theory also, some numeric analysis. For that also, I recommend if you want to know, become expert, if you want to try to acquire jobs in construction management, should also have a basic knowledge of construction management at BTech level. But at MTech level, you have a course. We have a course not only in our university, but in IIT Delhi, Mumbai, Chennai. Then we have many other private universities also. They have these courses where you can pursue. Then we have another. This is what I'm showing is Coursera only. Then we have EDX, other platform is there. Then we have Udemy. Udemy is very cheap. 300 to 400 you pay, you get a tutorials of each software. NPTEL everyone knows. In NPTEL also not on the BIM, but you have a course on construction management by IIT Madras. Even my supervisor from IIT Delhi also develop some courses. So in this, you can learn many things on your own. That's what I'm trying to say that. Like I say that, so really if you want to become a skilled in this area, if you want to pursue career in this, you have to do MTech in construction management anywhere, not only in our university. In our university, we are offering. I'm actually covering the subjects in this construction engineering management. We have MTech program here. But if you any other university where you prefer good to go there, you can go there. So all the virtual construction courses and all the project works in virtual construction, where we teach BIM, AI also there. We have a course on AI. We also teach statistics. We also teach all the management aspects in the construction. All this can be learned in MTech in construction engineering management if you want to really acquire skill in this area. You can go through our website, Rama University of Applied Sciences. Actually, BTech students I'm talking. If you want to pursue career in this, you can call me anytime. I can clear the doubts even next year. So I also offer PhD in construction management in virtual construction area. In the same area, I also offer PhD work where faculties or even students who complete MTech can pursue PhD. If you want to go in teaching area, you can always do a PhD. So there is only one student I have who is currently just joined, who is working in this area. Then I have 3 more students who is working in different area in construction management, but not in virtual construction. So there is also scope for teaching also, because we don't have faculties in construction management. That's another thing everyone knows. Because of that only many, it's a future again. But with the current trend, what is happening with AI, CSC, so but construction management is one of the future because it includes all the latest trends. So with this, I want to conclude my presentation. So here are my contacts. My email ID is there. My 2 email IDs, official and personal email ID is given. My contact number also given. So you can call me anytime. You can email or contact anytime. And if you have any doubts in this, you can ask me. And if you want to be, if I want to be part of any even project works, you can become a co-guide. You can part of any examiner. If you want to become examiner in this area particularly, I can also become. In future also, if you have any other these type of events, FDP, short-term courses, workshops, even if you want to part of that, I can be part of that basically. Thank you. So with this, I want to conclude my presentation. I hope it is useful for everyone. In 1.5 years is very huge. I know that it is difficult to understand, but I think I have given a brief introduction to this topic. Thank you.
Thank you so much, sir. Any questions from the participant side? Any questions? You can post it in the chat box and also you can ask here. Have any questions? I think no questions, sir.
No problem. It's a
very informative
good
session.
topic.
Everyone understood it.
Yeah.
Thank you very much, sir. I'm very much thankful to you, sir, for enlightening us with the virtual commercial office building softwares and different courses, project works, AI, BIM, and 3D models to 8D models with a neat explanation and different applications of building information modeling. And I take this opportunity to express our gratitude to your kind sir for sharing knowledge and importance of virtual construction regarding conceptual design, detailed design, fabrication, operation, maintenance, logistics, so on. And also we would look forward to have such mutual academic interaction with you, sir, in near future and for the benefits of students as well as faculty community.
Sure,
Thank you.
sure. Thank you, madam.
Very informative session. Thank you so much, sir.
Welcome.
Yes.
In the continuation of Ramya Madam,
Yeah.
so
Sir.
I, Ravi Kumar Head of the Department of Civil Engineering. So on behalf of management, Sir MVIT and Civil Department, I thank Dr. S.P. Srinivas, the guest speaker of this session. And also, I would like to thank our colleague Ramya for successful conduction of this session. And this session was very informative, sir. Thanks a lot.
Thank you, sir.
And I also thank all the participants for their participation in this session, as the session was very informative. So was well. So in this regard, let us join tomorrow at 10 p.m., 10 a.m. for the third session. Before going back, please fill up the feedback forums. So thanks a lot, sir, SP Srinivas, sir.
Thank you, sir.
We'll try to involve in our what you call college interactive session or
Sure, sir. Happy to come, sir. Happy to visit. Actually, I came 2-3 times with my wife. Never met you, but earlier, yeah. So happy to visit university institute and give some even sessions, more sessions.
Yes, sir. Yes, sir. And also, we'll see for an offline session also. You're
Sure,
welcome.
sir. Sure, sir.
We'll welcome
Definitely,
you anytime, sir.
Sure, sure, sir. Definitely, sir. I'll be there, sir, anytime.
Thank you.
Thank you.
So thanks the participants once again. So have a nice evening for the day. So let us join tomorrow at 10 a.m. for the third session tomorrow. Thank you. Fill up the feedback forms before going out.